In this lesson, we'll discuss the web of trust concept and technique used in open PGP systems, which is used to verify many public domain open source software, including the one we just discussed in the last lesson, HTTP, Apache web server, and a common downloaded terminal software called putty. Here we show how artists can import black public key to one's public key rings, which is a set of public key. Using GnuPG edit-key option command, we can examine black key. We type FPR, which stands for fingerprint, okay, to display the fingerprint of the key. And those are generated by the long 4096-bit kind of public keys for a shorter digital string. After checking the fingerprint either by calling or email the person or their friend, we can use sign command to make black public key fully trusted in our GnuPG key ring. Even though this strict trust and personal verification is the safest, when we are dealing with a lot of people to interact securely, it may be too slow to verify each of the fingerprint of people's public key. And also we don't know and trust other people whether they will carefully vet other people's credentials. There are 4 trust levels: unknown, those keys whose trust is not known at this point. And that means it could be generated and put it there before you are there with your GnuPG software. And none is a trust level where the owner is not known to improperly sign other key. So they are in prohibited list in a way. The marginal trust level is that the owner understands the implication of key signing and properly validate the key before signing them. So this slightly can be trusted. The next level is called full trust level. Here the owner has an excellent track record understanding the key signing, and his signature on key would be as good as your own. Here we show initially when artists examine black key in a key ring, it shows the trust level as Q, these abbreviations, which is unknown. But the key is valid, which is indicated by the abbreviation F. With the trust command, artists enter 3, which means she trusts him marginally, as we talked about in the previous trust level, is level 3. Now the trust level is changed to M, M shorthand for marginal trust level, and still valid. And therefore, we use the notations M/F in this GnuPG software output. The right side table shows the trust level and their abbreviations. Web of trust infers the trust by considering the trust level of the key along the path and the length of the path. In web of trust, the key K can be trusted when it is signed by enough valid key along the path, meaning that one of the 3 conditions must be satisfied before they consider valid. A, you signed it yourself personally, therefore it's trusted. B, it has been signed by someone you fully trust them. Or C, it has been signed by 3 marginal trust keys along the path to the particular key. Finally, the path of the signed key leading from the key user back to you cannot be too far away. In the default case, need to be 5 steps or 5 hops or shorter. Know that the number of marginal trust keys along the path and the maximum path length can be adjusted by the user depending on their application. The 3 marginal trust key condition in 1C and the 5 steps requirement are the default values set by GnuPG. And here is a simple example for us to understand the web of trust model better. Here we change the number marginal trust key along the path to be just 2, not 3 in the previous default case. And the maximum path length to be 3, not the 5 in the previous case. Okay. The key signing graph is used to show the key signing relationships among this group. The end of the arrow is the signer. The tip of the arrow points to the owner of the key being signed. For example, in the left-hand side, Ali signed the key of the Blake on the top and Dahmer. Blake signed the key of Chloe. So is Dahmer, and so on. The table summarizes the potential valid key result line by line, row by row, based on Ali's trust on the left-hand side on other key. Since Alice signed the key of Blake and Dahmer, their keys are valid, always valid. The validity of other key, however, depends on the trust level that can be influenced. Case 1, or the row number 1, Alice trusts Dahmer fully, which implies Chloe's and Francis' key will be considered to be valid. Row number 2, Blake and Dahmer are trusted marginally. Since the 2 marginally trust keys are needed to fully validate a key, Chloe's key will be considered fully valid based on Rule 1C. But Francis' key, however, will be considered only marginal valid because only one of his signer is considered to be trusted. Row 3, Chloe and Dahmer are marginally trusted. In this case, Chloe's key will be marginally valid since Dahmer's key is fully valid. Francis' key, however, will also be considered marginally valid since a fully valid key can be used to validate others' keys. And Dahmer's key is only fully valid key that has been used to sign Francis' key. Okay, row number 4. When the marginal trust in black is added, Chloe's key becomes fully valid and can then be used to fully validate Francis' key and marginally valid the next one, Alina's key. Row 5. When Blake and Chloe and Alina are fully trusted, this is still insufficient to validate Geoff's key since the maximum certification path is 3 as we make assumption, but the actual path length from Geoff back to the Alice is 4. So evaluate that second condition, therefore it's not valid.